Okay, now in this part we shall try to derive x of omega, which is x of e to the power j omega, is periodic over a period of twice pi. So, since we know x of e to the power j omega is equal to summation where n goes from negative infinity to infinity, x of n e to the power minus j omega n. In order to derive this as a periodic function, what we need to do is add a simple term x e to the power j omega plus twice pi times k, which essentially means that the signal is shifted in the frequency domain by a term twice pi times k, where k being any integer number. If k is 1, the signal is shifted by twice pi times. Similarly, if k is 2, it is shifted by 4 pi. So every shift in twice pi times, we shall try to derive the signal is either periodic or not. So this can be written as summation where n goes from negative infinity to infinity, x of n e to the power minus j omega plus twice pi k times n. So we have changed the variable omega to the new variable. Now x of e to the power j pi plus, there will be a bracket here, twice pi k is equal to summation where n goes from negative infinity to infinity, x of n e to the power minus j n omega times e to the power minus j twice pi k n. Now, using the Euler's relation, we can simply write e to the power minus j twice pi kn to be equal to cosine of twice pi kn minus j sine of twice pi kn. Sorry, plus. So, as you have seen, this will become 0 because sine of twice pi times anything will always become 0, and similarly cosine of twice pi by any number will also become 1. So this value will give us 1. You can verify it using any calculator. So replacing this value in the equation, this term will essentially become 1. So finally we can write x of e to the power j omega plus twice pi k is equal to summation of n which goes from negative infinity to infinity, x of n e to the power minus jn omega times 1. So this expression is equal to x of e to the power j omega as shown over here. So what we have established is that if we have shifted x e to the power j omega, by any multiple of twice pi in the frequency domain, the value essentially remains the same, which dictating that the signal is periodic over any twice pi limit. So x of, say, omega plus twice pi will be equal to x of omega, which is our condition for periodicity. Now, since we have established that the signal x of e to the power j omega is always periodic over twice pi, so if we go back to the synthesis equation, all we need to do in order to find the area under x of omega is to take the limit from negative pi to pi. That means if we take a limit for x, if we take a limit over twice pi, we will end up with the value of the area under this curve. So that is our reason for taking the limit of the integral to be twice pi. So I hope that is clear. In the next part, we shall be studying about the properties of the discrete time Fourier transform. I hope up to now you have no confusion, and let's move on.